Good afternoon, everybody. Today we are going to fill in our unit circle. So last class we created our unit circle on a paper plate, and we take that with us everywhere, obviously. But that took us a really long time. It took us like an hour and a half to develop the unit circle. And I don't want it to take you that long to fill out a unit circle every single time you need it. So I'm going to go over some tips and tricks today on how to fill out your unit circle. Honestly, really the only thing you need to know about the unit circle is the first quadrant and your quadrantals. Remember, quadrantals are on your x and y axis. So let's start there. So remember, this is your x-axis right here, and the radius of the unit circle is always 1. Okay, this is the center of the circle, or your origin, your 0, 0. So you're going to go ahead and realize that this red line here on the right is a radius, and that distance is going to be 1. The radius of the unit circle is always 1. So this point right here is going to be 1, 0. Okay, after you label your coordinate, I want you to go ahead and label the degrees and the radians. So we know that this is 0 degrees and 360 degrees. We know that this is 0 radians and 2 pi radians. Okay, where are your other quadrantals going to be located? Your other quadrantals are going to be on the rest of the x and y axis that we haven't looked at yet. So on the left side of your x-axis, the negative side, this is going to be -1, 0. Your degrees are going to be 180, your radians are pi. Your other quadrantals are on your y-axis. Okay, so up at the top, this is 90 degrees, or pi over 2 radians, and your coordinate is 0, -1. Down at the bottom here, it's 270 degrees, 3 pi over 2 radians, and your coordinate is 0, -1, because you're on the negative side of the y-axis. And now, after you memorize your quadrantals and you put those on your unit circle, you have to know the first quadrant. Okay, remember our trick to remember the signs was A, S, T, C. So in the first quadrant, all of your trig functions are positive. So we have sine, cosine, and tangent, plus all the reciprocals. The only coordinates we have on our unit circle are cosine and sine. Remember, cosine is our x value, and sine is our y value. But I'm also going to write my tangent off to the side on my unit circle so that I have it memorized and I can copy it into the other quadrants. The 3 special angles we're working with are 30, 45, and 60 because those are our special right triangles. So first would be 30 degrees, then 45 degrees, then 60 degrees. And our radians are pi over 6, pi over 4. I remember this because 45 starts with a 4. And then pi over 3. For your radians, for the 30 and 60, the radians are just switched. So the 30-degree angle has pi over 6, and the 60-degree angle has pi over 3 for its radians. Then for your coordinates, okay, cosine of pi over 6 or cosine of 30 degrees was √3 over 2, and sine was 1/2. If we wanted to figure out tangent, remember that tangent is y divided by x. So last class we did the horrible math. We did 1/2 divided by √3 over 2. Remember, you keep change flip. So it's 1/2 times 2 over √3. Your 2's will cancel. You get 1 over √3. But that's not okay. We can't have a radical in the denominator. So we rationalize and we get tangent for 30 degrees is √3 over 3. Now, I remember this because 3 plus 3 gives me 6, and it's located at my pi over 6 value. Okay, I write that on my unit circle, so I never have to do that fraction dividing again. Now, for pi over 4, or 45 degrees, I know that my cosine is √2 over 2, and my sine is √2 over 2. They're the same, and you can remember it because 2 plus 2 gives you 4 for your pi over 4 radians. Your tangent, if we did y divided by x, because tangent is y divided by x, If you do root 2 over 2 divided by root 2 over 2, they're the same, you're going to get 1. Remember, our 30 degrees and our 60 degrees are really in the same special right triangle. We're just switching the angle that we're working with. So with our coordinate, your x and your y just switch, your sine and your cosine. Switch. Another good way to remember it is if you're looking at the first quadrant, your x's will go 3, 2, 1 on the top, and your y's will go 1, 2, 3 on the top. So once you have your first quadrant, all you have to do is reflect those numbers into the second quadrant, the third quadrant, and the fourth quadrant. So if you remember, we were making our paper plate. We had a 30-degree pink triangle. We took it after the first quadrant and we reflected it over the y-axis. Okay, so that means that this angle is in the same family as this angle. They're both in the 30-degree family. Remember, that's because our reference angle, our distance to the x-axis, will be 30 degrees. That's why they're all in the same family. Okay, then we reflected our pink triangle down into the third quadrant, so that was right here. And then we reflected it over the y-axis into the fourth quadrant, so that was right here. All of those are in the same family. So all of those should have the same coordinates. The only thing that's going to change is the positive and negative. Same thing works for our 45. We took our 45, we reflected it over the y-axis, and we know this one's in the same family. Then we reflected it over our x-axis, and we know this is in the same family. Then we reflected it over our y-axis again, and we know this one is the same family. We should make a perfect x. Finally, we had a green triangle. I had a 60-degree reference angle. So we had in our first quadrant, we reflected it over the y-axis, so it looked like this. Reflected it over the x-axis, and then reflected over the y-axis again. So all of the pink angles have the same coordinate, just your positive and negative will change. All of the yellow angles have the same coordinate, and all the green angles have the same coordinate. I just take all of my coordinates and I reflect them over the y-axis. So the short pink line should match with the short pink line in the second quadrant. So copy over your coordinate, it's root 3 over 2, 1/2. I also copy my tangent, which is root 3 over 3. And then I have to figure out who is negative and who is positive. In the second quadrant, sine is supposed to be positive, and sine is my second value. So that means everybody else has to be negative. Also, I'm on the negative side of the x-axis, so my x value should be negative. Again, tangent is y divided by x. So if I did y divided by x, I would get a negative number because that's positive divided by negative. So my tangent is also negative. If you remember the trick, the ASTC, you know that S stands for sine, and sine is the only positive value right here. Then copy your yellow angle over. That would be root 2 over 2, root 2 over 2, and my tangent is 1. Okay, and then I know sine is the only one that's supposed to be positive, sine is second, so both of those have to be negative. Copy my 60-degree angle over, that's 1/2 root 3 over 2. My tangent is just, oh no, I didn't plot my tangent. Tangent for pi over 3, we figured out last class, was square root of 3. So when I copy that over here, square root of 3 is going to be negative because only side is allowed to be positive. I remember that tangent is square root of 3 for pi over 3 because they both have a 3. Notice I haven't filled out my degrees or my radians. I actually do those last. I keep reflecting while these radical numbers, these crazy radical numbers, are fresh in my head. Okay, so when I reflect over the x-axis, remember that the pink line goes with the pink line down here, so you're going to copy your coordinate. But in the third quadrant, x and y are both negative. Since x and y are both negative, and tangent is y divided by x, a negative divided by a negative gives you a positive. So your tangent should be positive in this quadrant, and that makes sense because I'm in the t quadrant. So my tangent should be positive. My yellow coordinate should match all my other yellow coordinates, but since I'm in the third quadrant, they're both going to be negative. Negative divided by negative gives you positive, so tangent will be positive. Same thing for your green coordinates up above, copy those down. Since I'm in the third quadrant, they will both be negative. Negative divided by negative gives me positive, so my tangent will be positive. Then go ahead and reflect that into your fourth quadrant. Your fourth quadrant, your pink line still matches with your pink line, but cosine is supposed to be positive. Cosine is my x value. So my x value is positive and my y value is still negative. That does kind of make sense since I'm on the positive side of my x-axis, that my x value should be positive. Okay, you're going to copy over your yellow coordinates, but the y will be negative. Copy over your green coordinates, but the y will be negative. Now your tangent will also be negative. Cosine is the only thing that's allowed to be positive. And if you think about it, tangent is y divided by x. Negative divided by positive would give you a negative answer. So this tangent will be negative root 3 over 3, copied from my pink line up above. Tangent here will be -1, and tangent here will be negative square root of 3. After you do all of that, it looks way more terrifying than it actually is. We have to find our degrees and our radians. So I do my degrees first. Remember that you are adding 30, then adding 15, adding 15, adding 30. Okay, so 90 plus 30 will give you 120. And then add 15, 135, add 15, 150. I'm supposed to add 30 here. Hey, that makes sense. 150 plus 30 is 180. Okay, add 30 again. So this is going to be 210. Add 15, 255, add 15, 240. Hey, I'm supposed to add 30 and down here somewhere I have a negative 270. Or sorry, a 270. So that makes sense. Okay, then I'm adding 30. So 270 plus 30 is 300. Add 15, 315, add 15, 330. Hey, I'm supposed to add 30, and that gives me 360. Last part, oh my gosh, this is exhausting. So the last part we're going to get today is our radians. So all of the pink lines are going to be in the same family. They're all in the pi over 6 family. So this is going to be some kind of pi over 6. But you can only stay on the unit circle if you do not reduce. Okay, so if I did this is 1 pi over 6. If I used 2 pi over 6, that would reduce to pi over 3, which I already have, so I can't use that. So it can't be 2 pi over 6. It can't be 3 pi over 6 because that reduces to 1/2 and I already have that. It can't be 4 pi over 6 because that reduces. So you have to use 5 pi over 6 in the second quadrant. Then you continue with the rest of the pink lines. So 5 pi over 6 is where I am. I cannot use 6 pi over 6 because that reduces. So this has to be 7 pi over 6. You can't use 8 pi over 6, or 9 pi over 6, or 10 pi over 6. So this in the fourth quadrant has to be 11 pi over 6. You're going to do the same thing. Pi over 6 is the worst. So we're going to do the same thing with pi over 4. So 1 pi over 4 is the yellow in the first quadrant. I cannot use 2 pi over 4, but I can use 3 pi over 4. I cannot use 4 pi over 4, but I can use 5 pi over 4. I cannot use 6 pi over 4, but I can use 7 pi over 4. It can only stay if it doesn't reduce. Finally, my pi over 3s, these are the easiest. So I have 1 pi over 3. The second quadrant will be 2 pi over 3. The third quadrant cannot be 3 pi over 3, so it can be 4 pi over 3. Then the fourth quadrant will be 5 pi over 3. At that point in time, you have everything you need to know about your unit circle, all generated from the first quadrant. Now, nobody's grading you on being able to create a unit circle. Your questions are going to look like this. So you're going to have to use your unit circle to answer specific questions. So really what you're doing is you're just going to find cosine of pi over 6. Cosine is your x value. So cosine of pi over 6 is root 3 over 2. That's your final answer. Sine of 7 pi over 6. Go find 7 pi over 6 on your unit circle. Sine of 7 pi over 6 is going to be some kind of 1/2. But what quadrant is 7 pi over 6? It's in the third quadrant. The third quadrant is the tangent quadrant, which means only tangent can be positive. So this is a talking about sine, that has to be negative. You can copy that exactly from your unit circle if you find 7 pi over 6. You know sine is the y value, so you copy your y value of -1/2. Okay, or you can use the quadrants to figure out if it's positive or negative. Sine of 11 pi over 6, 11 pi over 6 is in quadrant 4, so you go find 11 pi over 6 and you copy the y value. That will also be -1/2. That makes sense because I'm in the cosine quadrant, so only cosine can be positive, sine must be negative. Cosine of pi is not in a quadrant. Cosine of pi is a quadrant. Pi is on the negative side of your x-axis, and cosine is your x value. So the x value right there would be -1. Tangent of 5 pi over 4. Go find 5 pi over 4 on your unit circle. Hopefully you wrote your tangents on the outside of your coordinates. And I know tangent is positive 1. 5 pi over 4 is in the third quadrant, the t quadrant, so tangent is positive. Ooh, love this question. Tangent of 3 pi over 2. 3 pi over 2 is down at the bottom of your unit circle. That coordinate is 0, -1. And I know that tangent is y divided by x. So -1 divided by 0 is undefined for your answer there. What about cosine of 15 pi over 4? Our unit circle has failed us. This is not on my unit circle, but I can figure that out. So I know that in the first quadrant I have 1 pi over 4. The second quadrant is 3 pi over 4. The third quadrant is 5 pi over 4. And the fourth quadrant is 7 pi over 4. Notice that I'm counting by 2s. This is 1, 3, 5, 7. So I'm just going to keep counting and going around in a circle until I find where 15 is. Okay, so this is going to be 9 pi over 4, 11 pi over 4, 13 pi over 4, 15 pi over 4. So 15 pi over 4 is coterminal with the pi over 4 value that you have in the fourth quadrant. So it will be coterminal with 7 pi over 4. So you can just find cosine of 7 pi over 4, and it will be the same for 15 pi over 4. So cosine of 7 pi over 4 is root 2 over 2, and it stays positive because I'm in the cosine quadrant. Sine of 5 pi over 3, oh thank God, this one's on my unit circle. It's in the fourth quadrant. Sine of 5 pi over 3 would be negative root 3 over 2. Since it's in the fourth quadrant, you know it's going to be a negative. It's only positive. I'm going to do 4 more, and then we're going to stop for today, and you can try the rest by yourself. So tangent of 10 pi over 3. Unit circle, you failed me again. Okay, so in the first quadrant, that's pi over 3. This is 2 pi over 3. This is 4 pi over 3. 5 pi over 3. Can't use 6 pi over 3, so this has to be 7 pi over 3. 8 pi over 3. Can't use 9 pi over 3. So this has to be 10 pi over 3. Remember, you can only use people that do not reduce. So 10 pi over 3 is in the third quadrant, so it's coterminal with 4 pi over 3. So you can just tell me the tangent of 4 pi over 3. I believe that is positive root 3 because I'm in the third quadrant, and that's my tangent quadrant. So my answer should be positive. If it says negative, I want you to ignore it and just find cosine of regular pi over 6. Regular pi over 6 is in the first quadrant. Cosine of pi over 6 is root 3 over 2. But if it's negative pi over 6, it literally reflects down below the x-axis. So positive pi over 6 is up above. Negative pi over 6 is down below the x-axis. So since I've got my quadrant, I know I'm in the fourth quadrant, and I know my answer has to be some kind of root 3 over 2. I just have to figure out if it's positive or negative. Since this is the cosine quadrant, and I'm talking about cosine, my answer is going to say positive. Let's try that again. Okay, I know regular 4 pi over 3 is in the third quadrant. But since it's going to be negative 4 pi over 3, I know it's going to move up into the second quadrant. So I find sine of negative 4 pi over 3 by looking at the pi over 3 angle that's in the second quadrant. I believe this is 2 pi over 3. They're essentially the same thing. So what is sine of 2 pi over 3? root 3 over 2, and it's going to be positive because it's in the sine quadrant. Okay, last one. We have cosine of negative 5 pi over 2. Pi over 2 is weird because it's only on my quadrant. Okay, I know it's negative 5 pi over 2, so I'm going to switch these. Because I know that when they're negative, they switch. So this is negative 1 pi over 2. Up at the top, I have negative 3 pi over 2. So when you continue down to the bottom, notice how this is negative 1, this is negative 3, the next one you're going to have is negative 5 pi over 2. So negative 5 pi over 2 is really coterminal with this guy down here. The coordinate down here is 0, negative 1. So that means that your answer is the first one, your x value. So your cosine of 5 pi over 2 is 0. Why don't you try the rest of these by yourself? Remember, for number 13, tangent is y divided by x. So you want to go look at 0 and do your y value divided by your x value. Remember, when you have negatives, you really just flip it to the opposite side of the x-axis to get your answer. And if your value is not on your unit circle, keep counting. You can only keep answers on your unit circle that do not reduce. Okay, good luck. Have a good day.